So, good day to all, and to Engineer John Ray Monterola. Good day, sir. This is my model of a shunt DC generator with a condition of high voltage, low current. So, in this generator, the armature and the field coils are connected in parallel. So, this is my schematic diagram of a shunt DC generator. So in this schematic diagram, we can see the armature, the armature resistance, the shunt field resistance, and the load resistance. So this is our load voltage here. So as we see in this schematic diagram, we can see that IA going here is equals to ISH plus the load current or IL. So here it is IA is equals to ISH plus IL. So given the power output or the load power of 15 kilowatts and load voltage of 150 volts, armature resistance of 0.06 ohms, and the shunt field resistance of 50 ohms, we are going to calculate the generated EMF in the armature, the power generated in the armature, and the efficiency of this shunt field, shunt DC generator. So now we are going to calculate the generated EMF in the armature. So given the formula of VL plus IARA, so since we have already the value of load voltage and armature resistance, so first we need to get the value of the armature current to get the generated EMF. So IA, as we've seen in the schematic diagram earlier, IA is equals to ISH plus IL. So first we need to get the ISH, and the formula for the ISH is equals to VL over VRSH, because in the schematic diagram we can see that the load here is parallel with the shunt field, so therefore they have the same voltage. So that's why in getting this ISH, we use the load voltage over the RSH. So substitute 150 volts time 150 volts over 50 ohms, so we can get the ISH is equals to 3 amperes. And then the formula for IL, the power output or the load power over the VL, is equals to 15 kilowatts or 15 times 10 to the power of 3 over 150 volts. So we have the value of IL 100 amperes. So IA is equals to ISH plus IL, so 3 plus 100 amperes is equals to 103 amperes. So this is the value of our current current in the armature. So go back to the original formula for the generated EMF. Substitute 150 volts plus 103 IA, the value of IA, times 0.06 for our armature resistance. So we can have now the value of our generated EMF, which is equals to 156.18 volts. So now that we have already solved for the value of the generated EMF, we can now solve for the value of the power generated in the armature. So with the given formula of generated EMF times the armature current, so substitute 156.18 volts times 103 amperes, so we can get 16,086.54 watts. So this is our power generated in the armature. So next we are going to calculate the efficiency of our generator. So given the formula of the efficiency of P out over P in, so equals to P out over P out plus P losses. So Given that we have already the value of the P out, which is 15 times 3 to the power 15 times 10 to the power of 3, and then we are going to calculate the value for the losses. So P losses is equals to uh, armature current squared times RA plus shunt field current squared times RSH. So substitute 103 squared times 0.06 ohms plus 3 squared times 50 ohms. So we can get the uh, value for the P losses, which is 1086.54 watts. So go back to the formula for the efficiency. P out P out which is 15 times 10 to the power of 3 over 15 times 10 to the power of 3 plus 1086.54 times 100. So we have the efficiency of 93% for our shunt DC generator. So therefore I conclude that this generator is a good generator with this efficiency of 93%. So that would be all. Thank you.